Port security is to protect our MAC table from learning spoofed MAC addresses. Not only spoofed, they are all not real MAC address, meaning flooded MAC address, too many, which is going to completely consume the space that is allocated for MAC address table. See, in a router or a switch, for every process there is a allocation of MAC of memory process, sometimes physical ports. So there is some limit for everything in a router or in a switch. Don't think I got a router, then I can have any number of routes in the routing table. No, that's not true. Your router has got a limit. You cannot take on small enterprises router and use it in a service provider environment. Why? In enterprises, you will have very less number of networks, so very less number of routes in the routing table. That's not the case with the service provider routers. They will be learning the entire internet routes. So for service provider, there are some special routers like ASR devices. They have more memory allocation, buffer, RAM, instead of memory, processor. Even the architecture is different from iOS router. ASR, the physical architecture, is different from both the physical and the software, the operating system architecture is different. So that can accommodate more amount of routes, MAC addresses, more throughput, and so on. So far what I said is there is a limit for the MAC table. MAC table cannot be consuming all the buffer that is available. There are various services for which the buffers are the temporary memories is what I called as buffer. They are allocated. They are divided and allocated. But if attacker is going to come and consume all those allocated space, then where will be genuine computers MAC address learn? Not possible. If an attacker floods packet and fills the complete space in the MAC table, then there won't be any space for genuine computers MAC address to be learned. This we can stop by enabling port security. This is all we learned. We are testing it now. Port security is not only on the access port, it is also on the trunk port. What is a trunk port? The port that carries multiple VLAN traffic. Between switches, most of the time we will have trunk port. Now in our case, the switch 0 and switch 1 got a link between from F03 of switch 0 and F01 of switch 1. We have this inter-switch link. This link may be a trunk link if you have more VLANs. The reason why I have this is port security is not only for this port where the PC is connecting, it is also for those ports that where the switches are connected, where hub is connected on the switch. So port security is applicable in all these places. F01 of this switch, F02 of this switch, F03 of this switch, F01, anywhere you can enable port security. So port security is not only for the ports where the end device connects. That's what I want to say. It is even needed on the port where the other switch is connected or other hub is connected. If you're configuring port security on this port, F01 of this port on the switch, you need to really calculate how many MAC addresses are possibly learned on this port. You see, if all these three computers are communicating to this one computer, then the MAC address that will be learned going to be 4 MAC address. How? This one switch MAC address is also included. 1, 2, 3, 4. So you need to tell this port that maximum MAC address that may come here is maybe 5, extra 1. So that if more than 5 MAC address comes to that port, action can be taken. That's what port security, not allowing more than what's supposed to come. Whenever a frame comes, from that frame, the source MAC address will be always learned into the MAC table. The source MAC address. So when this PC pings, this is one of the this PC's MAC address will be one of the source MAC address. When this pings, the second MAC address. When this pings, the third MAC address. But this is also going to be there because this is a layer 2 device. It has got a MAC address. So when you ping here for the first time, this is the first ping that you're doing from left to right. There will be 2 MAC addresses learned on F01. One is the switch MAC address, the other one is this MAC address. 2 MAC addresses. Let me enable port security. Before that, I would like to put some IP addresses on this. Gateway is not necessary because we are not going to route. Right. So you see, I would like to show you the MAC address table of the switch, and on F01 you will see one MAC address already learned, which is the next switch method, show MAC table. You see on F01 I'm seeing three MAC address. This is the one, second one, and the switch MAC address. Hub don't have any MAC address. I see three MAC address on F01. This is Cisco switch. I would like to show you that. You see this MAC address, last four number 76CD. This is connected here, no? So this switch MAC address is learned. See? No. Sorry, this port F03. F03. I typed spanning tree, no? Show interface F0/3. Now you see 7803. 7803 should be one of the MAC address here. You see 7803. And then the other computer's MAC address, other two computer MAC address. Let me show you this computer's MAC address. IP config, or you can see the last four letters here, 8E, 8BEA, 8BEA. You see 8BEA. This is this first computer's MAC address. And this is 466B. 466B. So these are the three MAC address of 1, 2, and the switch port F03. Learned on the other switch. So if someone is flooding MAC table, MAC addresses here, it is not going to not only going to impact the switch, it's also going to impact the other switches. As the traffic goes to that switch, it will start learning the source MAC address. See, we did not generate any traffic, did we? No, we did not generate any traffic. We simply connected connected the device. We put IP address, that's all. As we put IP address, the gratitude ARP, it went and said, this is our MAC address. Means it's a kind of keep alive package that's sent that makes switch 1 to learn the MAC address of the connecting device. Let us enable port security. I'm going to enable port security on this port. I know very well that this is the maximum MAC address that can be learned. So I'll say interface F0/1. First of all, you have to enable this port security by typing switch port security. See, don't forget this command, switch port security. But you see, when I give this command, it says command rejected. Why, you know? It needs to be an access port or a trunk port. I told you trunk port is the port that can carry multiple VLAN traffic. What is an access port? The port that belongs to a single VLAN. In our case, we don't have many VLANs. We have not learned VLANs, so I'm not going to get into VLANs and trunks now. I'm going to make this as an access port. Switch port mode access. By default, it will be in a dynamic auto. So if it is dynamic auto, the command will get rejected. It needs to be access or trunk. Access means the port that belongs to a single VLAN, VLAN 1. which we have by default. You see all the ports are in VLAN 1. The MAC table it shows. We don't have many VLANs. In case if you have many VLANs, then I should say here switch port mode trunk. Now I can enable port security, show port security, sorry, switch port security. I enable. This time it did not show me any error. See, you have enabled port security. And now if you verify, show port security, it says F01, which is this port, maximum MAC address that can be given to this, attached to this port is only one. We did not say maximum MAC address. If you simply enable port security, this is the default rule. Only one MAC address, and one MAC address is already learned. So far no violation happened. In case a violation happened, the port is going to shut down. But we saw there are three MAC addresses. How can this say I have only one MAC address? Let's go and verify. Show MAC address table. Now it is only one. You know what happened? Because the port was idle for a long time, the MAC address timed out. Those MAC addresses that we saw earlier timed out. That is why you are safe. Otherwise, by this time, it would have shut down. If violation happens, what it will do, it will shut down. See, MAC table also have got refresh rate, meaning if a MAC address is learned, it won't be forever. If there is no communication from that MAC address, it will disappear after 5 minutes. You can also change the timer, So see what happens if I try pinging someone. Who is the 7803? Maybe it's a MAC address of the switch. 7803. Yeah. Only this switch MAC address. I would like to name it as switch 0. Hostname. Only switch 0's MAC address is learned here in the MAC table. Now, as soon as I try pinging from here, see what happens behind here. This will turn red. Ping 10.0.0.4. See, immediate red. Because the violation happened. Let's go and verify now. You see here, the interface have gone down. Line protocol has gone down. Show port security, you see, one violation happened. So the port has gone down. F0/1. You see this port is enabled with port security. Currently the status is it is down because of security reason. Why? The violation has happened. Right? Okay. Let's go and increase the MAC address. We would like to allow 3 MAC addresses. 2 computer. This computer is going to be an attacker later, so don't include this computer now. 2 computer and a switch. 3 MAC address. So I'm going to go here F01 switch port security maximum command 3. Now if you go back and check that interface, it says 3, but still the status is secured down. Yeah, still it is down only. Next, show port security. The reason why it is down is once the violation happened, it won't come up after some time. For that, we need to enable another feature called error disable recovery, which we'll see later. It was not in that presentation. You can automate. Whenever you shut down, you come back and see maybe after 5 minutes. After 5 minutes, you come back and see if everything is normal. Stay up. If not, again go down. But we have not learned that, so I'm not getting into that. So what is the solution? Now I'm very sure there is no attacker, and I know there's 3 MAC address possibly to be learned on that port. I increased it to 3, but the port is still down. What should we do? We need to, first of all, let me show you. Show IP interface brief. You see the interface is down. It is because when the violation happened, the port security has forced the port to go down. So we have to force it to come up. It is not administratively down. It is because of violation, the software has turned it down. We should now, as a owner of this device, we should say, hey, it's okay. For that, first you need to say administratively down. Shut down means ownership. You are taking ownership. Whatever is running, stay quiet. That's what the meaning. Now port security was running. Now we said port security, you don't have any strength anymore. And then I say no shut. Now I give the power to the interface to come up. The interfaces come up. Now you see, show port security. 3 MAC address can be learned. So for no MAC address learned and no violation, in case violation happens, it will shut down. Now 1 MAC address is learned. That's the MAC address of the next switch. The PC's MAC address will be learned only if PCs start communicating. If you want to learn, if you want to see what that 1 MAC address that is learned in that port, one command is show MAC address table. There's another command, show port security MAC address. Learned address. No. Show port security addresses. This shows that this is a MAC address that is dynamically configured on that port. See, this command is under the port security, not simply show MAC address. Show port security address. Now you see, we can also bind the MAC address statically. What I'm going to do is I'm going to copy the MAC address of this PC. I'll copy the MAC address. And I'll go to this port and bind it here so that in future, if that MAC address comes, this will know already. Interface F0/1, I'm saying switch port, port security, MAC address, paste. Now if you go and verify, show port security addresses, it says secure configure, meaning statically binded, manually attached, not dynamically learned. And we know there are 3 MAC address possible in this port. So for two MAC addresses, one is learn dynamic, another one is configured by us statically. If the third MAC address is not possible for you to copy and stick it, there is a way. We can say on the interface F0/1 switchboard port security MAC address sticky. The sticky command, what it will do is, if there is any MAC address to be learned, in our case, there is one more MAC address to be learned. Out of three, two only learned. One given by me, another one dynamically learned when the packet come in. The third MAC address packet so far did not come, but when it comes, that MAC address will be copied and sticked to the dynamic RAM, DRAM, meaning it will get stick to the running configuration. So what I'm coming to say is you no need to copy and paste. You cannot go to every computer, copy and paste. In our environment, we have everything in the screen. In the real world, this computer will be somewhere, this computer will be somewhere. So not possible for you to just copy those things and type. It's difficult. I'm not saying not possible at all. It is possible, but it's a difficult task. When your switches are in a secured environment where no outsiders are there in the company, you can simply stick it. And then after sticking, you generate some packet. Now if you go and see this MAC address, the third MAC address is sticked. You see, this is the third MAC address. We did not give it. It is sticked. And it is stick to not just a buffer, to the DRAM itself. You see, show run. You see, this is the command we gave for sticky, and this is the sticked MAC address. That's the sticked MAC address, 466B. And this is the MAC address that we configured. What about the other one? The switch MAC address is learned dynamically. That it won't be shown here, but it will get sticked next time. Let me show you the MAC address. This is the sticked one. This should be from this computer. ipconfig. You see, 466B. 466B. Now, if I say copy and start, this is going to be permanently written into the NVRAM. Which MAC address? Two MAC addresses. The third MAC address will also be learned once it is ticked. So that every time when you reboot, you no need to learn the MAC address. It will be always ready there in the table, and the switch knows only these MAC addresses are allowed. Let me reboot and show you. Reboot or reload. See, show run. You will still see the MAC address. You see the MAC address that I manually attached, the MAC address that I sticked. Let's go and check. See, so far no communication, but you see the MAC address. Show MAC address table. All right, and then show port security addresses. You can see three MAC addresses here. One is secure configured, the other one is sticky. Two stickies. This time two stickies, because I said stick whatever you learn. Even the switch MAC address is ticked. Now let's go and check the running configuration. You should see one more MAC address ticked. Yeah, look at this. This is the neighbor switch. This is that second computer. This is the first computer's MAC address, which I gave manually. And now if I say copy and start, it's going to be permanently written to the NVRAM. Only these three MAC addresses will be allowed in future. Right, even if I disconnect this wire, see, the MAC address will be there. Disconnected the wire. And then I'm going to say reload. Show MAC table, MAC address table. You see there is no MAC address in the MAC address table, but show port security addresses. It's there. It is there because in the running configuration, you have those MAC addresses. Even though there's no conversation so far on that port, even the port is down actually. There's no wire connected. The port is down. Port is down. But still you can see those MAC addresses that are allowed on that port. Show port security addresses. Show MAC address, nothing. Let's connect the cable now. But what I'm going to do is before I connect, I'm going to off this computer. Off this computer. So out of 3 MAC address, 1 MAC address is not available. I'm going to add another computer which is not binded. Boom. I've added it to the hub and I'm going to connect it. I'm going to connect this two switches together. See, there is a rogue device now connected. One of the genuine devices off today. So the attacker thought, okay, 3 MAC addresses are allowed. One guy is absent today, let me take his place. Is it possible? Not possible because we have clearly said these are the 3 MAC addresses. So if this guy tries to initiate some packet, see right now it is green at the back, you see? It's green at the back. Right now if you go and check, show port security, no violation so far, show port security, no violation, but 3 MAC are supposed to be learned, it is already learned. So far no violation, so it allowed the port to be up, but as soon as this generates one small packet, pin 10004, boom, you see, it has become red here. Immediate. See how it protects your network. Because it's an unauthorized entry. Show port security, see? There is one violation, so I'm shutting down the port. So to bring it up, what do you do? Interface F0/1, shut down first, and then no shutdown. That's the procedure. Don't simply say no shutdown, it won't come up. See, again the port is coming up. I'm waiting for the port is turned green now. Let me on this genuine computer. I owned it. And I'll ping from here. Ping 10004 -T. You know what is -T? Keep pinging. Timeless. Means no stop. -T. This will be keep on pinging. Yep. So this is going to be keep on pinging non-stop, timelessly, without any limit. It will be sending ICMP packet, getting replies. As it is pinging, I'll introduce this bad guy. Again gone. So it is not only gone for the attacker, it is also gone for this genuine member. See, the genuine member was communicating earlier. Because the attacker came in, this port got shut down, and even the genuine person is not allowed in. This genuine person got disconnected because the port is down here. This is also a genuine computer. Not pinging at all. So if one attacker comes, this entire portion of the network get discarded from the network, which is not acceptable, no? So there is an option. Interface F0/1 switchboard port security action. So violation action. Violation. The default is shutdown. Protect and restrict is other two options. When you say protect, it is going to drop those packets that are coming from unauthorized MAC address. When I say restrict, it is not only going to drop, it is also going to generate a log. Every time an unauthorized MAC address comes, it is going to increase the violation counter and generate logs if syslog is enabled. Otherwise, only it will increase the violation counter. Let me say protect and show you. I said protect, I shut down this port, and then I bring this port up. Now you see, I change the action, violation action. So show port security. You see it is protect now. So far no violation happened. So show port security interface F0/1 is right now up, secured up. 3 MAC address can be learned. Total MAC address is 3, in which one is configured by me statically. 2 got sticked into it, and the last known MAC address learned on the port is the neighbor switch MAC address. So far no violation happened, and it is in the protect mode. Now you see this ping is going on happily. This ping is also going on happily. Now the attacker is coming. Even though there is denial for attacker is denied. But the genuine computers are still pinging. attacker is denied. Now if you go here and see, the violation counter did not increase. Actually, the violation is going on. Show port security. The violation counter did not increase. The protect mode will simply ignore those unauthorized packet. But as administrator, you will not have an account of the violation. If you wish to have, then you need to enable restrict mode. Interface F0/1, port security, violation, restrict. This is not only going to protect you, it is also going to show you proof. How many times the violation happened. Now you see, these genuine computers are pinging happily, both here and here, and the attacker is coming now. Attacker is denied. Not only denied, you will see violation counter. Sorry, what am I doing? Show command. You see, so for 3 violation, 4 violation, 4 packets from unauthorized MAC address. I think the ping got over there. 4 packet it was sending, no? So 4 violation. If you ping again, it's going to be 4 plus 4, 5, 6, 7, 8. That's it. After this, don't come because we generate only 4 ICMP packets when you ping by default. So, if you wish to see this violation, how many times, you need to go with a restrict mode. I just want to protect my network. I don't care who is doing how many violations. I don't want any account of those things. Then just leave it as, just configure only protect. But if I leave it as default, the shutdown, in our topology, we saw that the genuine computers will also suffer if you shut down this port. So shutdown can be an option on the access ports. So if that port goes down, only that PC will be down. See, this PC's MAC address I bind here. But someone in my absence, they disconnect the cable and they connect their PC. Immediately the port will be shut down. That is okay. The port is down, only that attacker is denied. But when a trunk port, when the link between the switch is shut down, all the devices in the left and in the right cannot communicate. So we need this option like restrict or protect. Any question on port security configuration? All right. Now, to understand another attack called VLAN hopping attack, we need to understand these things like access ports and trunk ports. What is an access port? The port that will be a member of a particular VLAN. What is VLAN? Virtual LAN. A switch is considered to be a LAN device. switch is called as a LAN device. By default, the ports of the switch, all the ports of the switch will be a member of a LAN which is identified by a number called VLAN 1. Let me show you that. Show VLAN brief. You see, there's a VLAN called 1 to which all the ports are member. So the physical switch is a LAN device. It's a LAN in which there is a virtual LAN inside created called 1. Now when you connect this cable to another switch, don't say this is another LAN. No. This is still one LAN. Why? This is also VLAN 1, and that VLAN 1 gets extended now. Earlier, let's say this is a 24 port switch, this is another 24 port switch. When you don't have this wire connected, it was only 24 port LAN. Now it is 48 port LAN. 24 plus 24. The LAN size gets increased. I connect another switch, another 24 port switch. So how many VLANs we have? Even now, it is only one VLAN, only one LAN. Yeah. So the LAN gets bigger and bigger as you keep connecting switches. Now there is a computer here sending an ARP request. ARP request is a layer 2 broadcast, right? This broadcast will impact everyone in this organization, all 72 computers, all 72 ports. This broadcast will be sent to all ports other than from where it is coming. So 71 ports are going to forward the broadcast. So a single broadcast will impact, it will go and disturb, will go and consume the bandwidth and processor of 72 other devices, 71 other devices. Which you may not be liking. You don't want all the 72 members to be in a single group. Maybe you have one group of 20 people in a project, another group of 15 people in a project. So you want them to be in a different group. You don't want all, meaning you do not like to have the 72 members in one LAN. You don't like it. You want more LANs so that you can isolate project 1 20 people from project 2 15 people, project 3 13 people, project 4 18, whatever. So you want to separate them, but you cannot buy a separate switch for each project people. If you buy 4 switches, give one to project 1 members, 2, 3, and 4. They are going to be isolated, no doubt. But the problem is, this is a 4-story building. Project 1 member is sitting in the 4th floor, as well as 3rd floor, as well as 2nd floor, as well as the 1st floor. And in the ground floor, it's only parking. So what I'm saying is, if they are sitting in one room, it's okay. We can connect all those 20 people in a switch. But they are connected. They're sitting in various floors, different floors. Likewise, project 2 members also sit in various locations. P2, P2. And project 3, people are sitting in all floors. So what you need is, you need many switches now. To isolate these 3 guys, you need 3 switches here, another 3 switch here, another 2 switch here, another 2 switch here. This is costly. So what can we do is, you can create a virtual LAN. That is why we call this VLAN. In one switch itself, you can create multiple switches. You can take one switch of the 4th floor, give the necessary ports for project 1 guys, project 2 guys, project 3. And to differentiate this virtual LAN, you give a number like VLAN 10, VLAN 20 member, VLAN 30 member. Even though they are in one single physical switch, it is as equal as having 3 physical switch. This will not talk to the other group. They won't talk. They're isolated. So VLANs saves your money, space, power consumption, number of cabling, and so on. The broadcast that happens in project 1 second floor will go to project 3 and project 4, only those ports where the project 1 members are. How is that possible? We'll have this type of switch with multiple VLANs on all the 4 floors. And we'll have what? A trunk link connector. That is why we need trunk. Any port can be made as trunk port. Repeating, any port, available port, you can configure as a trunk port. Later, if you don't want, you can make it as an access also. There is no dedicated port for inter-switch link. There is no dedicated port. Any port can be made as an inter-switch link. You can configure as trunk. So when you configure trunk, listen carefully. When project 1 member wants to talk to another project 1 member, so alpha is sending an ARP request. Hey, who is that beta? I want to know you. What's your MAC address? That broadcast will go to every member of VLAN 10, and the broadcast will go out via the trunk port with the marking. ARP broadcast, it will go with the marking that this belongs to VLAN 10. And when this port reads VLAN 10, it will remove this and send the broadcast to only VLAN 10 member. Again, a layer to broadcast of VLAN 10 with the marking is sent to here, and this switch will also know where to forward. It will forward only to these group members, asking who is beta. Let me know your MAC address. What is the advantage? Advantage is you are not disturbing any other department in any floor. So their processors are not unnecessarily consumed. Their bandwidths are not consumed. As a result, the bandwidth is improved, process is utilized in a right way, and the network is growing in speed when you do VLANs. So breaking down that big LAN into small LAN is actually going to make your network more faster. In technical term, one VLAN is one broadcast domain because members of that VLAN can receive that broadcast. When it was like this, all 72 members in one LAN, the broadcast domain was too big and it was consuming bandwidth and processor unnecessarily. When we break down the broadcast domain, how? By creating multiple VLANs, you limit the number of devices that will get impacted by the broadcast. So VLANs can be defined as breaking down the large broadcast domain into multiple small broadcast domain, that is VLAN. So we'll continue this VLAN study, access port and trunk port, then we will get into VLAN hopping attack. I'll stop here for a day.